Hey there, welcome to Applications of Inequalities Part 1. And all we're really going to do here is take some sort of situational problem and figure out some inequality that relates it all and see if we can solve that inequality. So these are actually pretty easy, they're not too bad. A lot of the questions will simply give you some sort of an inequality formula. For example, we might be wondering, and the formula I'm going to use here has to do with resistance. So for those of you who are interested in physics, this would be a great question. So we might be wondering, when is the resistance formula here, which says r squared minus r plus 1. When is this less than 5? When is this resistance formula less than 5? When does that happen? For what values of r? Well, you know, if you just look at what you have here, you don't really have anything that's so different from what we've always done. What we're just asking here is, when is this less than 5? Now notice the wording here, and this is important. This doesn't say 5 or less. It says strictly less than 5, and that's why here it is strictly less than 5. If it had been 5 or less, so let's say it was written like that, then we would have a situation where we would write less than or equal to 5. So this is, just be aware of the difference there, okay? And that's not what we have here, okay? So I've set this up, r squared minus r plus 1 is less than 5. Well, my goodness, that's just an inequality which I can go ahead and solve. So I'm going to move that 5 to the left side. I'm going to subtract 5, so that's now minus 4 and less than 0. This thing doesn't factor, so I'm going to go ahead and use the quadratic formula. So I've got negative 1, so there's my b, plus or minus the square root of b squared, so negative 1 squared, minus 4 times a times c, and that's all over 2 times 1. So we go ahead and solve this. We get 1 plus or minus the square root of all over 2. Now let's get back to this guy. This would be 1. We got a double negative here, so that'll be plus 16. So it's looking like 17. And I'm going to go ahead and work out what that is on the calculator, get the decimals here. And we've got, on the one hand, negative 1.56. And on the other hand, we've got 2.56. So there's my two numbers where this whole business equals 5. So now, how do I finish the question? Well, probably a good idea is to grab a number line here. So just squeeze a little number line down there and analyze my zones. Now remember, this is actually the r-axis, and the key numbers we have is negative 1.56 and positive 2.56. Okay, and these would be open circles because there's no equality. So open circles. Now I'm going to do a poor man's graph. This is a positive r squared. So I know it's a parabola that's going to open up. So if I just kind of do a poor man's graph here, here's kind of what I see happening. And of course, these key points here that we've established, those are the r-intercepts. Those are the places where the equation equals the right side. Well, I'm interested in, when is it less than 0 here? Okay, less than 0, that's going to be the zone in the middle. So I would just shade this in here and just say, yeah, this is it, between these two numbers. And I can write that in an algebraic way by doing this, negative 1.56. And we want r to be greater than that, which puts it to the right. But we, at the same time, want it to be less than 2.56. So I kind of it frames it in. On the one hand, you're greater than the number on the left, but at the same time, you're less than, so you're to the left of this number on the right, and that kind of frames it in. So that's our first word problem. So really, the answer is kind of sitting right here. Somebody says, when is r squared minus r plus 1 less than 5? When r is between these numbers. That's when that happens. So your resistance would be between those numbers. Okay, that is my first example, and I'm going to stop there.